Hi, welcome back to class. In our last lesson, we saw Kirchhoff's laws. I introduced both the Kirchhoff's current law and the Kirchhoff's voltage law. In case you missed that lesson, please don't hesitate to check the description below. We'll keep a link to that lesson, and also at the right hand corner, we'll keep a link to that lesson. That said, let's get into class. Now today we'll be using two examples, and this is the first of the two examples to further explain on current law. Now, if you look at this example, it has several nodes. This is one of the node. Here is a node. Here is another node, and here a node, and here also a node. We'll use these four nodes to find the missing current. Now, at node B, let's take the first node. At node B, I have 50 amps coming into the node, and we have 20 amps and I1 leaving the node. Based on current law, we know that the sum of the current coming into the node is equal to the sum leaving the node. So my 50 amps will be equal to 20 plus I1. So that 50 minus 20 will be equals to I1. Invariably, my I1 is the same thing as 30 amps. Let's move to node C. Now at node C, we have that 20 amps is going into the node. That's 20 plus 15 amps is also going into the node is equals to I2. I2 is leaving the node. So that the sum of this current will be equals to 35 amps. Let's look at node D. At node D, I1 is coming into the node while 120 amps is leaving and I3 is leaving. So that I1 should be the same thing as 120 plus I3. And already we know that I1 is equals to 30. So 30 amps is equals to 120 plus I3. Obviously, 30 amps minus 120 is equals to I3. So that's 30 minus 120, that's minus 90 amps, is equals to I3. Obviously, getting a negative answer tells me that my I3 is in the wrong direction. We will have one of two choices. Either we leave this as just negative or we change the direction for further cases. But let's leave it as minus 90. Now we can move to node E. At node E, we have I3 coming into the node. We have I4 coming into the node. So I can sum both of them together to be equals to 15 amps. 15 amps is leaving that node. Now, so that I4 now, obviously, will be the same thing as 15 amps minus I3. I have I3 to be equals to minus 90. So this will be 15 minus 90. 15 minus 90, that's something as 15 plus 90, which is equals to 105 amps. Let's solve for I5. I think that's the last node at node F. At node F, I have that 40 is leaving the amps, is leaving the node, I5 is leaving, plus 40 will be the same thing as 120. I5 will be the same thing as 120 minus 40, which is equals to 80 amps. I5 is the same thing as 80 amps. We have seen, that means we have solved for I1, we got I1 to be 30 amps, I2 to be 35 amps, I3 in the wrong direction, we got it to be 90 amps, and I4 to be what? 105. And finally, we have our I5 to be 80 amps. Let's solve the second question. I'll advise you pause this lesson at this point and try your hands on this question. Okay, let's see how it goes. Now we've labeled the circuits. This is A, B, and C. At point at A, my 10 amps is entering the circuit. Is the same thing as 7 amps leaving the circuit plus I1 plus I2. We have two unknowns, so we can't go further with this. We just tag this as equation 1. And let's see what happens at B. At B, have I2 is entering the circuit, plus 3 amps is entering the circuit, while 2 amps is leaving the circuit, is equals to 2. So that I2 now is the same thing as 2 minus 3, which is equals to minus 1 amps. Obviously, I2 also is in the wrong direction. Let's leave it as negative. If I1 is equals to minus 1 amps, and in equation 1, from this equation 1, we have that 10 is equals to 7 plus I1 plus I2. I'll go back and replace I2 with minus 1. That will be 10 will be equals to 7 plus I1 minus 1. So that 10 now will be equals to 7, that will be equals to 6, sorry, 7 minus 1 is 6 plus I1. Invariably, 10 minus 6 is equals to I1, and that is the same thing as 4 amps. Write this conveniently as 4 amps. Now, if I1 is equals to 4 amps, we've gotten I2. We left to solve for I3 at node C. Node C, here's node C. At C, we have that I1 is entering the circuit plus 2 amps plus 7 is equals to 3. And my I1 is 4. That means 4 plus 6 plus 7 is equals to I3, not 3, is equals to I3. That means I3 is equals to 13 amps. With this, I hope you understand how to work with Kirchhoff's current laws. In subsequent lesson, we'll dig deeper into Kirchhoff's voltage law and we'll see more complicated circuits. I hope you hit the subscribe button. That way you'll be sure to get notification anytime we create our lessons. Thank you and see you in our next class.